Yeah, thank you very much. So, dear colleagues, I would like to discuss with you also origin of life, but on Venus. Actually, life on Venus is one of the top subjects for many astrobiologists, since the idea of existing microorganisms in its clouds is being now actively discussed, and there are many speculations on how such microorganisms could survive there. And here I would like to focus on how they could emerge there. In my talk, I will present some of our ideas about different scenarios for the emergence of life in the cloud layer of Venus. So actually, at the moment, there are three main hypotheses of origin of life on Venus. First hypothesis is that life was originated on Venusian surface and then transferred to the clouds. The second concept is that it was originated in clouds themselves, and the third is about panspermia from Earth to Venus by dust or particles, or rocks knocked out of the surface by the impact of a meteorite, or lithopanspermia, long distant interstellar transfer of living forms to, in our case, to Venus. What are the main environmental limits to living organisms on Venus in the context of the origin and survival? First of all, there are extreme conditions in Venusian clouds and debates on water availability on ancient Venus. So the first point is related to survival capacities of living organisms, whereas the second one is the important precondition for origin of life. So here you see different physiological types of terrestrial microorganisms who probably could survive in Venusian clouds. And the strip, you see the strip here, includes the area of physico-chemical conditions under which microbial forms should live in a habitable zone in Venusian clouds. So we can define such a physiological type of organisms able to survive there as thermoacidophilic microorganisms who are living at extremely low pH and high temperature in habitable zone of Venusian clouds. Another important challenge to life on Venus is extremely arid environment that is much more dry than the limit for terrestrial microorganisms. The only possibility for microorganisms to survive is they being or existing in microenvironments like aerosols or drops, where water can be concentrated to a much higher level. You see here the difference in mean concentration of water in Venusian clouds and the lowest limit for terrestrial organisms. But this is a really mean concentration. Origin of life on Venus surface. Actually, in this case, we refer first of all to the works of researchers considering the possibility of water on ancient Venus. On the right side, you see the figure created according to Professor Wei's estimation that actually indicates that surface water could exist on Venus for the quite long historical time, longer than 2 billion years, that should be quite enough for emergence and further evolution of living organisms on Venus, similar to Earth. And for emergence of life under such conditions, we can, for example, use so-called inversion concept developed by Vladimir Komponichenko, who will be giving his talk on this subject the day after tomorrow, as far as I know. But anyway, this is the first concept of origin of life on Venus, assuming that water was present at its surface long time ago. Actually, clouds of Venus themselves can present an interesting global system where many different processes of synthesis of different complex molecules can occur. To activate such processes, we have actually all set of main biogenic elements plus iron that can actually play important role for, especially for Venusian organisms. So high cloud density, solar radiation, and convection flows, winds can facilitate different chemical reactions. Additionally, possible foam structure of water environment in these clouds, actually of liquid phase in clouds, could be a kind of concentrator for matter, and in turn facilitate interactions between molecules by means of supramolecular forces acting in nodes here, for example. In nodes as elements of such structure. Such concentration actually of matter can be compared with the action of clays and the important role in one of the concepts of origin of life. Actually, you see also the difference in temperatures. So we can say about the high temperature origin of life and the cold origin of life, also possible minus 45. And eventually panspermia, microorganisms actually could colonize Venusian ecosystems via panspermia of different types. Ballistic panspermia, so it's delivery of microorganisms from Earth to Venus with dust, with different particles, or technogenic panspermia. It's possible to deliver right now, yeah, in our time, to deliver different microorganisms to Venus or other space bodies by different spaceships from Earth, but probably this hypothesis is not really valuable now for Venus, because we are saying about microbial communities which is existing quite a long time. And lithopanspermia, interstellar transfer, also different, possibly different types of microbial forms from one star system to solar system and eventually to Venus. Of course, there are different advantages and disadvantages in relation to different scenarios of origin of life for Venus. The advantages usually we have advantages because there are a lot of concepts of origins of life developed for Earth, so we can actually apply them to Venus. But disadvantages or limits are mostly related to undeveloped concepts or the absence of water on the surface of Venus. So all these concepts can be developed further or eliminated depending on new data, which can be obtained by spacecrafts or other studies of Venus by different equipments in different missions. Here I would like to present actually possible direction of evolution of Venusian microorganisms. Similar to Earth biology history, we can Earth's biology history, we can actually suggest hypothetical evolution of organism on Venus. Here I postulate possible emergence of VLUCA as an analog of terrestrial LUCA at the very beginning of biological evolution. So VLUCA, iron sulfur dependent last universal common ancestor on Venus. So it obviously should be strongly dependent on iron and sulfur in its metabolic reactions, and be a precursor of different types of microbial groups. If we consider terrestrial microbial physiological groups and biological processes, then we can speculate about the emergence of microorganisms driving, first of all, different types of anoxic reduction processes like sulfate, sulfur, nitrate, or iron reduction. Since ultraviolet radiation is quite intensive, especially in the upper cloud layers, then conditions for the emergence of photosynthetic iron and sulfur dependent organisms also could be favorable. Anoxygenic photosynthesis. Besides, methane could be oxidized by sulfur and sulfate reducers and some other anoxic processes like DNRA, dissimilatory nitrate reduction to ammonia, or NDFO, nitrate-dependent iron oxidation, could also be thermodynamically feasible. Two main microbial groups gaining energy through chemo and photosynthesis could be suggested for Venusian ecosystem in clouds. Once delivered via panspermia, microorganisms also should be adapted and evolved further to current conditions of the environment. Physiologically, microorganisms could have evolved from moderate acidophiles or just acid-tolerant forms to extreme acidoxerophiles. Here I defined xerophiles as organisms surviving in extremely arid environments. And this is a schematic picture of a drop as a microenvironment where hypothetical Venusian microorganisms can exist. Here we see hypothetical biochemical iron and sulfur-centered cycles involving the above-mentioned microbial groups. You also see some terrestrial microorganisms able to drive some biochemical processes under extreme conditions in Venusian clouds. The energy sources are redox chemical reactions and solar radiation. Some compounds can be constantly delivered by exchange processes between clouds and surface. Some biochemical processes can result in releasing ammonia ions. That is very important for partial compensating low pH of the environment, and hence creating more favorable conditions for microorganisms. So to summarize all the above mentioned, here you see the scheme of possible scenarios of the emergence of life on Venus, surface origin of life possibly in hydrothermal vents, cloud origin of life, and panspermia, with further evolution of microbial community from moderate acidophiles to xerotolerant extremophiles. So sustainability of microbial communities can be provided by maintenance of minimal biomass and involving microbial forms, microorganisms in biochemical cycles. The last slide is about methods of detection of Venusian life. Actually, a few space missions to Venus are now under preparation, and some of them will include astrobiology experiments aiming at searching for different types of biosignatures. Right now, many methods are developed that can be defined as indirect methods. They include searching for different types of molecules, which can be which can probably be associated with activity, biological activity, but not directly, like phosphine or methane or some other molecules. But much more information, of course, if not the direct answer concerning the life on Venus, can give direct methods. So after such methodology, we can say that we, for example, found something exactly belonging to living forms. So in this respect, I would refer to the next talk of my colleague, Dmitry Skladnev, who will talk about direct methods of detection of Venusian life. Thank you very much for your attention.